All right, welcome class. So, lesson 29, solving radical equations. All right. This is the new lesson for today, and for tomorrow it'll take. I'm gonna be very honest with you right now. This lesson will be very difficult. Okay, so let's begin. First question says, what is 6 is equal to x plus square root of x? How do we solve for x? That's the idea. Okay, this is the question. Now here, before we start this, let's take a look at how is this question different from the previous lesson. If we take a look at the questions from the last class, let's look here. This was one of them. 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 The one thing you have to understand is, in this question here, you have the variable inside the square root, and inside the radical, and here you have a variable outside. So you have it in both cases, inside and outside. Here, the variable is always inside from what we did last class, right? Every example we did, the variable was inside the radical. Now we're going to see what happens when the variable is inside and outside, okay? So let's look at a question from one of those pages, and it was this one. It said 3 times the cubic root of x plus 2 is equal to 12. So this was a question from the previous lesson. How do you solve this, right? The idea is, strategy is isolate the radical if possible. And here, to isolate this radical, this was the original question, right? To isolate the radical, the first move is divide 3 on both sides. And if you divide 3 on both sides, what happens? This cancels, and 12 divided by 3 is 4. And then now, if you have the cubic root of this, to get rid of this cubic root, you cubed both sides. And this just became what was inside the radical, and 4 cubed was 64, and x plus 2 is equal to 64, x is equal to 62, and then you also have to check it, right? Because cubic root of 3 times the cubic root of 62 plus 2 has to equal 12, but this is 3 times the cubic root of 64 is equal to 12, and the cubic root of 64 is 4, so it's 3 times 4 is equal to 12, 12 is equal to 12, and check, this worked. You see, here we wanted to isolate the radical, if possible. Here, it's the same idea. You want to isolate this radical. So let's solve it. All right, let's try and do this question. All right, and class, this is where you have to be patient. All right, patience, because this is not easy. It looks a little straightforward, but some of these questions we're going to do in this lesson, they're just really not easy. All right, so let's stay here. Here, what did we do? We isolated the radical, right? Here, you want to do the same thing. You want to isolate this x. And to do that, you're going to minus x on both sides. But if you're like, Mister, I want to be a renegade. I don't want to do that. Instead, I want to square both sides. And somehow by squaring both sides, I can get rid of this x, this square root of x. You are 100% right. Are you allowed to do this in math? Absolutely. So let's see what happens if you do this first. You get 36, right, is equal to, well, let's see, this is x plus square root of x times x plus square root of x, right? Because if you were to square this, you have to, it's this times itself. And this is what it is. And then how do you multiply this times this? Well, you have to do FOIL, right? You're going to have to do this times this, like x times x is x squared. X times square root of x is literally x squared of x. You're just multiplying this to this. And then what do you have to do here? Square root of x times x is the same thing as x squared of x. And this is square root of x times square root of x is just x. And this is equal to 36. So 36 is equal to x squared plus 2x radical x plus x. Is this correct? Absolutely, it is. And you can keep going forward. Is it a pain in the ass? Absolutely. You don't want to go like that. Here, instead, let's see what happens if we do this first. X plus square root of x. right? Let's do this. Let's minus x. And now here, what happens is you have 6 minus x is equal to square root of x. Now the idea is, once you have this, to get rid of the radical, that's easy money. You just square both sides, right? And square root of x squared, that's just x. But this, we're going to have to do the same thing we did here with the FOIL and represent this as 6 minus x times 6 minus x. Okay, but this we can do, right? 6 times 6 is 36. 6 times minus x is minus 6x. Minus x times 6 is minus 6x. And minus x times x is plus x squared, which equals x. Now notice that this looks a lot nicer than this. Are they both correct? They are. But something happens when you isolate the radical. And it's hard for me to explain it. You'll see it as you do more questions, that when you isolate the radical, it makes your life easier. It won't be as, it won't be such an extraneous task. Okay, so here, what do we want to do? Notice that this, we can combine the terms, right? So this is 36 minus 12x plus x squared is equal to x, right? And now, what I'd like you to do is think about what would be the next move. All right, pause the video, think about it. What would be the next move? If you were here solving this and you were by yourself and you're like, okay, I got to solve for x, what would you do? So pause the video, take a second, and now now I'll show you what the next move should be. The next move should be minus x. And you are going to get 36 minus 13x plus x squared is equal to 0. And the reason you want to do this is because we have what kind of degree? We have degree 2. You want to use the zero product property eventually. And notice that this is the same as x squared minus 13x plus 36. What you want to do is always put into standard form. Right? Standard form. You have the degree. X squared is the higher degree. It goes on the left. Then this degree is 1. This degree, there's a x to the 0 there. But okay. Now here, this is equal to 0. Okay. What I'd like you to do is, you can solve this now, right? What is the rhythm? You say what two numbers, are you allowed to say what two numbers when you multiply give you 36, but when you add gives you negative 13? Absolutely. You have degree 2, and the coefficient here is that a equals 1 here, right? So now this becomes x minus 9, x minus 4, and that equals 0. And now notice we went into the future kind of, because here, the reason why you wanted to do minus x to get 0 on one side is so we can do this property, which allows us to do x minus 9 is equal to 0 and x minus 4 is equal to 0. Okay? I can't stress to you how much that if I say, for example, let's say we take this x minus 9, x minus 4, and instead of it equaling to 0, let's say I say it equals 1. Are you allowed to say x minus 9 is equal to 1 and x minus 4 is equal to 1? Absolutely not. Absolutely not. You're only allowed to use this technique that you're saying that this is equal to this and this is equal to this only when it's 0 here. So that's the idea of getting 0 on one side. You guys have to get used to that idea, because if you have a degree 2 here, you can use all the factoring techniques that we've picked up. And now what do we have? X equals 9 and x equals 4. And we say ciao, right? We just say we're done and we run away. By now, hopefully not, because remember, how do you know x equals 9 or x equals 4 works in the original equation? You have to check. You have to check. So what I'd like you to do is check right now by yourself. And now here, if you were to check it, 6 is equal to x plus square root of x. So 6 is equal to 9 plus square root of 9. So 6 is equal to 9 plus 3. 6 equals 12. This is false. Okay? So x equals 9 doesn't seem to work. What about x is equal to 4? Well, 6 is equal to 4 plus square root of 4. 6 is equal to 4 plus 2. 6 equals 6. This is true. So here we have this x equals 9 is extraneous, and this is your solution. Okie dokie? Okie dokie. What I'd like you to do is, there are 4 questions here. There are 4 questions next, right? You have 1, 2, 3, and 4. What I'd like you to do is do the questions in this order. Do this one first, do this one second, do this one third, and ignore this question. Okay? I know it sounds a little crazy. This question is a little nasty. Well, it takes a... You know what? I'm going to show you how to do this question at the end of the lesson, because there's something you have to do. What I like you to do is do this one first, number 2, do that one first, do this one second, and then do this one last. Try and work on it by yourself. And remember, strategy is always, 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 if possible, isolate the radical. Okay? So here, the first question you should be doing is this question here. 3 is equal to 4x minus x. Alright? And notice the radical is not isolated, so what would be the first move? Okay? Pause the video, try and do it by yourself. If you have questions, raise your hand and let me know. But the thing is, you guys have to get into the idea is, you have no idea what the solution is. Right? You have no idea what x is equal to. When I was doing these questions, I had no idea what x was equal to. Okay? But you have to be comfortable. Think of when you're doing these questions, you know, you're going into a forest. When you go into a forest, you don't know what's inside this forest. Okay? You're going deep into these questions, and the only way you could continue through this forest is if you trust your math. That's the only thing that's going to get you through the forest. And then at the end of the forest, you get a solution. Okay? You have to trust your math, or none of this will work. Alright? Go. Okay, so let's say we want to solve these questions and see the solutions. Actually, okay.